Hi, my name is Nikita. I'm founder and CEO of Adventum Tech, and today we will talk about bridges. Bridges in our world is one of the key elements in national economy development. The bridge is a civil asset that we use to commute, to visit our friends, to go to work, do shopping, transport goods, do business. It is such a vital element in the system of each country. It is remarkably resilient and at the same time vulnerable. Once something happens with the bridge or a bridge is shut down to cross, normally it will create a lot of disturbance for the surrounding environment, for the communities, for people who use this in its daily activities, daily operations. They'll have to search for detours, and sometimes these detours may cause hours of added time in order to cross from point A to point B. So again, just to highlight that bridges is very critical element in our daily life all around the world. Let's talk about how do bridges are monitored. Well, a conventional method is to hire an engineer, go and do a in-person investigation, then do a conclusion, on all defects spotted, various type of structural or geotechnical issues spotted during this infrequent or one-time inspection. And then there's a report that you would normally study with prescription on how to maintain, what type of activities to, let's say, implement in order to reduce the further deterioration or damage or fatigueness of an asset and so on. But these conventional inspections, they're so infrequent. In the best case, the government authorities do it on an annual basis. They do several times a year and that's it. And this is what we see with rising climate load and climate impact on these structures. With defense readiness concerns, the bridges are experiencing more utilization. So they're experiencing more load. They were designed back in 1950s, 60s or 70s. So we have more vehicles on the roads, our cargoes are more heavy. We used to design structures for once in a 100-year storm, and now once in a 100-year storm, at least in Europe, is occurring every year. So I think the key is in constant, frequent, real-time monitoring, observing. We can call it observational methodology, observational approach, absorbing your super asset, and in case it signals you for fatigueness, be there and react. So here in front of me, I have a small model of Adventum Tech's digital bridge system that consists of a variety of sensors that we'll talk about later. The key of this system is very simple. When the software or the health status, the report says, let's say green, and it's safe for operation, there's no issues, and use the bridge for our daily activity. Once this bridge is starting to experience fatigueness that we can see through various patterns, and it turns yellow, this is where engineers have to start paying attention to what is happening to this asset and what causes the roots of this fatigueness, whether that's vibration, torque, tilt, load-bearing deformation, thermal load, expansion of an asset. However, when it turns red, this is when engineers really need to start paying attention and, as a first step, shut down the traffic in order to protect civilians' lives and avoid structural collapse that can further cause social economical losses, environmental issues, and so on. Just imagine a cargo freight train with oil and chemicals falling into river. That's another level of environmental issue we'll face. So it's not just about structural collapse, but it's about also the consequences that it can bring. So in Adventum Tech, we've packed a one-stop shop system to tackle all aspects of modern, remote bridge monitor. Let's start when the structure is being designed and built. We will use slab control 5.0 sensors, an intelligent rebar that we can install inside every critical load-bearing concrete element. For example, bridge piles, bridge foundation cap, bridge pier, to understand the real load bearing. So they will be installed in a element like this and constantly report on its load bearing, at the same time tilts, vibrations and rotations to highlight structural fatigueness. This is what we will start with and recommend every new built bridge to be already equipped today. Once we go further, and once the embankments are built and protected, it's all about selecting digital bridge bearings to constantly inform about the load bearing of the bridge and its structural behavior. Because as we discussed in our earlier episodes, bearings are meant to identify and control bridges' expansion, shrinkage due to various climate impacts, rotation, torque, and load bearing. So digital bridge bearings are an important element of a digital bridge system in order to fully and transparently understand structural behavior of these super assets. Once we come to an actual bridge span, ground controls. So these are sensors that you can hook, attach to measure tilt in all three axes, to measure vibration, and already have these data inputs early on from the structural operation. Once threshold bridge for tilt, load bearing, vibration, strain, thermal load can be, or are breached, this is when our system reports directly to our software that further communicates with the users to take immediate actions. In order to make more sense of how our sensors are embedded in a new build structure, let's imagine that we have a new build bridge project over the creek. So this is where we'll have water, and we'll of course have to place embankments. In order to build embankments, we'll have to start with pile groups. Once pile groups are complete, we go further with a pile cap, embankment pier, and so on. But let's stop already here and highlight once again the importance of using our Slab Control 5.0 real-time monitoring system that exactly is meant for this type of monitoring. So we install slab controlled sensors inside each pile to monitor its load bearing during the operation. Once we move forward in a bridge pier, we do exactly the same. So these two core bridge load bearing structures are fully Slab Control 5.0 equipped. Once we move forward on an actual deck, this is the place where we install bridge pairs. And this is the area where we need to install digital live load bridge bearings with a capacity of up to 2,000 tons per sensor. The bridge bearings, as we remember, is responsible for bridge deformations, torques to soften this structural deformation due to various climate expansions, shrinkage, torsions, and rotations. Once we have digital bridge bearings, we have full control of structural behavior understanding. The next is, of course, the actual deck. And I'm not talking about whether we have a suspension cable bridge and a different asset and another cantilever structure here. It's not about that. It's about the actual concept. The next element on top of bridge bearings is the deck. And on top of the deck, right in the middle, we'll install multiple ground control sensors to monitor tilt and to monitor vibrations so that we can have full understanding on structural behavior of the deck. Last but not least, we can install additional deviation or displacement monitoring equipment that is operating with GPS, GNSS systems. So dear friends, with this system, we just wanted to highlight that there are very modern systems at Adventum Tech available already today. So please feel free to reach out for us. Visit our website to learn more about Adventum Tech. Book the meeting with us, book your demo, and let's digitalize your super asset already today.